trying to show you the naive Bayes. But for that, I have chosen this R programming background. So we'll see today a simple application of naive Bayes classification, uh, and that can be later on can be extended to naive Bayes classification for text classification using naive Bayes. Okay, so naive Bayes classification is uh, basically responsible. There is a package for it which is called E1071. This is the package E1071. Okay, uh, this package is also responsible for support vector machine algorithm. Then okay, and naive Bayes also is there. So this is an important package. Is E1071. Okay, SVM is there, SVM, and it is also used for no, R programming, especially for statistics and probabilistic algorithm like fuzzy classifier, naive Bayes classifier, bagged clustering, then short-term Fourier transform, support vector machine, etc. Okay. So when it comes to SVM, there are many packages available in R to implement it. However, E1071 is the most intuitive package for this purpose. Okay, so it is widely used for SVM also. So what you have to do, we have to first you have to install this package. For that, I have written here for the convenience purpose. So naive-based classification using R. First, we will be installing this package E1071. So E1071, it has been already I earlier installed, so it has installed properly. Now once we do that, you know that we have to bring this package to our local system using library. So library E1071 also it is done. Okay, you can see that E1071 successfully unpacked and in MD5 sums checked. So these are the that we understand that the package is installing properly. Okay, so this E1071 is also used for support vector machine array. And then we'll be needing one data set is called house votes 84. House, house votes 84. For that we have to install another package ML bench. Installing. At this time we will see this package house vote 84 data set. This data set house votes 84. If you type house vote data set, that you see a machine learning repository. This data set is available. Last name is Democrat and two classes. Binary classification dataset you can download. But fortunately, this dataset is already available in R. Here you can see data 84 package ML bench. That's why you have called ML bench package. Data house hosts 84 ML bench. This package, this data is available in ML, so no problem. Dataset, dataset house vote. view the data set, you can see this data set. The republic, this is the class that we have to predict, republic, democrat, the data set. It's already available in package that you have well bench pack that this data set is there by default. We have seen the data set, this data set. Now, other names of the attributes. So this is the class, the decisional attribute. We have 16 attributes. Then let us see the summary of the data set. As I said earlier, that short type, short in a short span of time, there is much more data view. You can see that Democrat and 168 is the attribute. These attributes, other attributes are yes, no. You can see. Okay, so this is summary. Summary is a function uh, which gives us an overview of the data set. There, let's see how many rows are there. Total 435 rows. That means 35. Here I think 435 rows should. I don't know. It is, but anyway, 435 rows, n rows. Then now the crucial parts to you have to understand. Now what we are going to do? Going to split data set into training and testing. Training and test data set. So for that, what we are doing? We are taking the whole data set and that row in row that we have used, with that we are multiplying 80%. That means 80% will keep as training and the remaining will keep as a test data set. This is how we should do it. That so let us have that data set, 80% data set, the variable. The variable. This variable, what we are doing, we are taking the data set, those votes 80, 10 rows, how votes 84, multiplying by zero point 0.8. That means 80% of the data set will be in variable. Okay. And then we will use that variable data set as training, and the remaining 20% will be using as a test data set, which is very important. This is uh, very important division of in and data. This is vital, very vital. Okay. This is how you should. There are many ways to split the data set into training and testing. This is not the only way. You can split in other ways also. Okay. So the variable now 80% has gone there. Now train data will be 80% for the for we have decided, let's say train data is just the variable that I have taken over here. That variable only I'm taking here. House votes 80. So this is there. And the test data will be just minus of it. Test data will be just minus of it. Minus test means 20%. So here it is 20%. There it is 80% train data. This is how we can split it. Okay. So let's run it. Variable table is there. Now train data we are going trying to do. Train data also done, I think. Yeah, train data 80%. Yeah, it is. Okay. Test data, the remaining 20% goes to test data. Okay. Training and testing, you understood this is how you can split it. Now let us build the naive-Bayes model. Okay. Let us build the naive-Bayes model. So what we are going to build the initially we're going to build the normal naive-Bayes model. We are naming it NB1. So model has been built. So here you can see students, yesterday class also I was trying to do in the lab. This is class tilt dot comma. That means this case, this is the class. Okay, this is the decision attribute, Democrat or Republic. That class only I'm going to predict. Then when I write tilt and then dot comma, meaning is that how this class is actually. This means that I'm going to predict in terms of the class, Democrat or Republic. Okay, and there I'm passing this training data. This is successfully has been executed. So this is how you should put your class, the class that you want to predict. Which class, like in case of test data, which class the data set, the instance should belong to, whether it should belong to Democrat or it should belong to Republican. This is how you should building. So this is just building the model. Okay. Now, now after building, let us predict it. Test data on test data predicting. So predicting always happens on test data. Spread one, I'm just naming it spread one. Then here I'm passing this NB1 data that I have created, the model that I have created. Okay, the model naive-Bayes model. This is the naive-Bayes function. This model naive-Bayes, and then in the class, in the argument section, I have passed this class tilt dot comma and then training data. So here the model is getting built, and then after building on the test data, which is the unknown. This is the catch of supervised learning in case of no machine learning. This is the catch. Okay, so test data only will be passed, nothing else. When you put -1, it is test data. So now -1 test data. Okay, now an unknown data set, it will be predicting. Okay, now predict function has worked properly. And then now let us finally evaluate the predict function. Now predict function will be evaluated only on the based on this predict that variable that we have created, and here is the prediction has happened, and this will be finally will be based on the class. Okay, so the test data dollar class, that means you're trying to catch hold of this class, this variable. So on this variable, how the prediction is going to happen, the unknown data test data. Okay, here we have I have just missed this one, this comma, that's why this error. Basically here I'm taking the 80% and then subtracting it. That means 1 minus 0.8, that is 0.2, which is nothing but 20%. 20% is actually considered as test data. And then this variable NB1 that I'm creating here, this is the class that I'm targeting, the decision attribute, which is categorical by nature. You can see that here, class Democrat and Republic. So this class I'm willing to classify it, and there I'm providing this train data. Okay, so train data is nothing but now 80%, and I have done that. I have built the model, and based on the model building that has been done, and that everything has been stored in a small object or variable, you can call, which is naive-Bayes 1 NB1. I have stored it, and then this NB1 I'm passing over here, and then test data I'm just passing in the argument of the predict function. So this predict function is very common in R programming. Okay, so here this predict function is happening. Now in this predict function, in the table, now here we are going to Evaluation means a confusion matrix today. Okay. Now in confusion matrix, what happens? So confusion matrix, you see, this is confusion matrix. One just simple diagram. Confusion matrix. This is confusion matrix. That means this is true positive. This is true negative, and this is false positive, false negative. True positive is the couples or the instances which truly, that means truly classified. Okay, truly classified. If, let us say if it is a cancer data, then the patients who has cancer and diagnosed also as a cancer, this is true positive. True negative is just the opposite of it, not opposite of it, but it is okay. Those who are not cancerous, they have not been diagnosed as cancerous, benign. Okay, so these two are fine. But problem is this, with this false positive is what? Those who are not having cancer but diagnosed as cancer, false positive, very dangerous for the medical expert system. Is adding a lot of negativity to the expert system. False negative is those who are actually having cancer but system is not able to diagnose them. So true positive, true negative, false positive, false positive, false negative. True positive, false positive, false negative, true negative. True positive, diagonally, true negative, false positive, false negative. Now let us come to the point. So here it is true positive, true negative, and then false positive, false negative. This is false positive, this is false negative. Okay. So it's correct. So from further you can calculate from here the accuracy you can calculate. Okay, you can calculate the accuracy of this expert system that you have developed here. This is nothing but expert system. The AI model based on machine learning techniques, especially knife based machine learning, which tells that I mean the test data, based on the test data, whether it should belong to Republic or the vote should belong to Republic or Democrat. Okay, I hope you understood. This is a complete explanation of classification. Now here another thing you can do, that is the knife based classifier that you have considered here, that can be, there are a typical knife based version is also available, which is Laplacian. So here you have to write LAPLA, Laplace equal to 1 if you make, and remaining thing, let's say this is predict 2, this is NB2, then NB2. Okay, and then remaining thing is predict 2 only. So this is just the Laplacian version. Laplacian version, if you make one, Laplacian version of the knife based classification. Okay, Laplacian version I think we have discussed when I gave the lecture on Bayesian classification. If you remember, Laplacian things I told. So here the slightly different results can expect. This is 46 for 532. Earlier it was how much? Earlier 46 for 530, exactly same results, nothing, no difference is come in the night base. This is their student. So this is the classification. Now onwards, don't tell that I don't know classification, how to classify and all. Now what you have to do, you have to just do it. Now you have to do the text classification. Okay, text classification using knife base technique, text classification.